Now we are going to understand the resistors in parallel connection. So with respect to activity 12.6, we are going to understand and we are going to derive the formulas regarding that. So here, as you can see, R1, R2 and R3 are attached in parallel connection with each other. That means they are above and below each other. And with this unit, so I am going to call this as a one unit because they are connected to each other in parallel connection. So this consists of one unit in which R1, R2 and R3 are connected in parallel connection and they are one unit, and voltmeter is connected to them in parallel connection. Now in first situation, what we are going to do is we are going to measure the potential difference across this unit and we are going to name that potential difference V. And along with that, we are going to measure the current reading, which is in connected to series with this unit, because as you can see here, it is not in parallel. When they are combined end to end, then it is called in series connection. Here you can see that this end is joined with this end. So they are connected in series. So ammeter is in series connection with this unit. So if we will open this loop, then you will understand that these connections are in series with each other. For example, if I am going to opening this loop, then at the end you will get to see that here ammeter is there, then this cell is there, and so on. So as you can see here, these three are in parallel connection with each other, but ammeter is in series to this unit, but voltmeter will still be here. So voltmeter is connected in parallel to this unit, where this unit consists of R1, R2 and R3. Now after connecting this circuit, we are going to measure potential difference and current across this circuit. So from this first situation, we are going to get two readings. First potential difference and second current. So from first we got two readings, that is potential difference and current. Current is across this circuit, so that is combined current for this whole circuit and that value is I. Now in second step, what we are going to do is we are going to connect the voltmeter in parallel to resistor 1 and not to the whole unit. So here R1 is there, R2 is there and R3 is there. So in second step, we are going to connect the voltmeter across R1 and ammeter we are detaching from here, but we are connecting in series with R1. So here we are going to get value I1 for the current which is passing from that resistor 1. So here we will get voltmeter reading and current reading, that will be I1. And obviously current value will change because it has passed from the resistor. In second step, we are going to repeat this experiment, but this time with R2. So we are detaching voltmeter from R1 and we are attaching over here, and we are detaching ammeter from here and we are attaching here. So now it is along with R2. So here we are going to attach voltmeter and ammeter. So again we will get two reading, that is going to be potential difference and I2. The current which will pass from the resistor to its value will be I2. Now similarly in third step, we are going to attach voltmeter across R3 and we are attaching ammeter in series with R3. So again we will get two value, that is potential difference and current, that is I3. Since the current is passing from R3, its value is going to be I3. Now after seeing the values of I1, I2 and I3, we will get to know that the combined current, what we got it from the first step, will be equal to the summation of I1, I2 and I3. Now as per the Ohm's law, I equals to V divided by Rp. Since these resistors are connected in parallel connection, I have written here Rp. Now we know that we have three different current values and we have three different resistors. So let us frame this formula with respect to this value. So I1 equals to V divided by R1, I2 equals to V divided by R2, and I3 equals to V divided by R3. Now the values of I1, I2 and I3 that we are going to substitute in this first equation. So I equals to, we will get V by R1 plus V by R2 plus V by R3. Now here the potential difference is common, so that we can take it out and we are writing it out of the bracket. So into the bracket 1 divided by R1 plus 1 divided by R2 plus 1 divided by R3. Now this we are taking towards the other side, and that will go to denominator of the I. So we are removing V from here and we are taking to other side. Now we know that I divided by V is 1 divided by R. So it is 1 divided by R. We know that here we have written that I equals to V divided by R. So R equals to V divided by I. But when we are taking reciprocal of this, we will get 1 divided by R equals to I divided by V. So that is something we are going to use here. That 1 divided by R equals to 1 divided by R1 plus 1 divided by R2 plus 1 divided by R3. So when we are going to calculate the combined resistance which is produced from the parallel connection of all the resistors together, then we have to utilize this formula. And here I am going to write Rp. That 1 divided by Rp equals to 1 divided by R plus 1 divided by R2 plus 1 divided by R3. And it is going to reduce the resistance effectively because they are in the denominator, and whenever the numbers are in denominator, its value will reduce drastically. Where in series, the formula was R equals to R1 plus R2 plus R3. Simply we are adding all the resistance together. Whereas here we are taking them in denominators and then we are adding them. So in parallel connections, resistance will be very less, but in series connection, resistance will be very high.